So write down 58. There we go. I want to find the rate of change. So I want to find the change in y divided by the change in x. Question on step 1.
Which rule did you use?
So for the first step, I'm not using a rule. I'm simply noticing that my goal is to find the rate of change of the function. Formula for f prime. And so I need to find change in y divided by change in x. This is what I need, so that's why I wrote it down. But because they tell me that y is simply this, I just write the same thing, change in y over change in x. The other way to describe what we did is more algebraic. We simply we used the derivative operator on the left. Therefore, to maintain equality, we must use the derivative operator on the right. Please, Gus.
So, on the worksheet, some of it gives us f of x and some of it gives us y, but we're going to be doing the same thing. We always do
Yes.
that.
Yeah, it's the same thing. They're just using two different symbols that represent the y coordinate. In fact, for this whole unit, Cassidy,
Yeah.
this is a very short unit. The test for this unit will only count 20% of your final grade, and then the one at the end of the term counts 60. This is like the most straightforward unit we will ever do, because all we do is exactly the same thing over and over again. So every problem starts exactly the same way. Take the derivative of both sides.
So if there's no power, do you skip that stuff and go straight to the adding rule?
Listen to Jack, he makes 2 points. You do not follow the rules in any particular order.
Yeah.
You simply apply them as necessary. So you're right. In this case, the first rule that applies, this is back to Gracie's question. Now when I look at this, I see 2 terms being added, and I'm going to think of one of them as being f and one as being g. Totally separate from the original formula. That's just how I use the rule. So I use the add-subtract rule. So the next line looks like this. Oh, again, you've got to get used to using a lot of different symbols for dy dx. Another one you'll see all the time is this one, y prime. You've already seen that on the last unit. Question? Please, Maya.
Would you need to put parentheses?
On this piece here?
Yeah.
No, not required. They're not technically required here, but then it kind of looks like D minus. Bothers me, so I put the parentheses. Yeah, you don't have to have that. Please.
Because the d of y divided by the d of x equals y prime, do you want us to start with our first step always, or at least right now, doing d of y divided by d of x? Or are we okay going straight to y prime or f prime or whatever that first issue is?
I'd like you to start for a while. Eventually, ask me again in a few days, I'll probably say it's fine to change. I'd like you for a few days to write dy dx because I don't want you to forget that even though we're doing all this kind of weird rule stuff, we're just finding rate of change. Yeah, we're finding change in y over change in x. It's just the actual math of how that works is hidden. So yeah. What? Hands up, what's the next rule? The whole key to this whole process is being able to see this, know what rule to use. And it's usually only one choice. You make the wrong choice, the whole thing just falls apart. So what's the correct rule? Hands, come on. Hands. What is the correct rule? What rule comes next, Jared?
Power.
So if we're going to use the power, I have to identify the g of x that is being raised to a power. So what's the g of x here?
Negative 4x.
So 3 points, 4, 5 actually, 6. You said sick, didn't you? Yeah, I thought you said 6. Put down 6. 6. Okay. The negative 4 is not being cubed. Only the x is being cubed. So the power rule won't work because the power rule requires that I have function to a number. Here I've got negative 4 times x to the third. So I can't use that. Questions? So what do I use? Pens. So what do I use, Eli? How many knew it? Points, 3 for Eli. Questions? Oh, please.
So why wouldn't you use the power rule on the last part, the d3x to the power of -3?
This one here.
Yeah, it's the same reason.
Yeah, so tell me, Bridger, what's being raised to the negative third power here?
Just x.
Just the x. I can only use the power rule when whatever I have here is being raised to that power. So I've got to get rid of the 3 first. Does that make sense?
Yeah.
2 points. Cool. So we did the add subtract rule there. Here we're using the multiplying constant rule. Hands up. What's the next rule? Show me your hands. Show me your hands. What is the next rule? Let's go, Lauren.
Power rule?
Now we use the power rule. How many knew it? Point. 2 for Lauren. Ah, that's good. So negative 4. Bring down the 3. X. D of x over dx. Make sure you write dx over dx. 1 second, Cassidy. Make sure you write dx over dx. That's another one of those gotchas where if you don't write what I write, a couple of days down the road, you'll be missing every problem because something's going to change and that's going to be important to not forget that. Cassidy?
I'm just confused on why we use the power rule. I thought before you were saying how it was just the x cubed and you need the constant. I don't know.
Don't worry, so just keep talking with me. So the power rule gets used whenever you have d over dx of pretty much anything to a number. Anything to a number. Therefore, I could not use the power rule here because I don't have all of this being cubed. Only this portion is being cubed.
Okay.
The power rule would only work if all of it were being cubed. So a multiplying constant allowed me to move the 4 outside of the ddx operator. When you're looking for a rule, you're always just looking at this part. You're ignoring the 4 because you're trying to see which rule looks just like that. And the power rule does. The x is now the something here that is being raised.
And the purpose of the multiply constant rule is just to pull out the number in front of it. So in order to do that.
Perfect.
Okay.
Yeah, you can see here that it seemed like we could use the power rule.
Yeah.
Negative 4 is messing it up.
But it's in the parentheses, so we use the multiplying constant rule to pull out the number in order to.
Yes, it's all about the, okay, these are really good questions. 2 more for Cassidy. Look, it's all about recognizing what are we operating on. In the very beginning, we have ddx of everything. We first use the add subtract rule, right? Now we have 2 derivative problems. It's like we started with 1 big one, we now have 2 small ones. But we're still just paying attention to the ddx of what do we, we have ddx of what? We have ddx of this. So all of our rules are written exactly the same way. ddx, ddx, ddx. Which one fits? Well, the only one that actually fit was this. Because we have the constant is -4, and f in this case would be x cubed. Again, like I said to Gracie, remember, as you're using the rules, you just kind of temporarily think of x cubed as being f. Once you've used the rule, just forget that. When we get to here, oh, now f is the x to the -3. Please, Luke.
So on the blue step with the 3d x minus 3, is the 3 like separate from that fraction there?
So the 3 is a constant that is being multiplied by the fraction. So you can think of it a lot of different ways. You can think of it like this if you want. You can say I've got 3 over 1 multiplied by d of x to the -3 over dx. Like that's fine. You can think of it like this. 3 multiplied by d of x to the -3 over dx. Same thing. It's just two factors being multiplied. One factor, here's another factor. But this is, again, that can be transformed using a rule.
Yeah, and that was my other question is, how do you know which one to use the rule on? Like the dx cubed over dx or the dx negative cubed over dx?
Oh, I'm going to use a different rule. I'm going to use a rule on each one.
Oh.
Because what happened was I started with one big derivative problem. The add-subtract rule switched it to two separate problems. So now as I go down the page, it's like I have one problem here I'm working on, I have a separate problem here. And I think of them separately. Is that what you meant?
Yeah.
2 points. Cool. This becomes plus. There's the 3. Bring down the -3. X, -3 minus 1, d of x over dx. Question? Maya, please.
So on the blue line, the 3, that's 3 dx over. Why does that 3 go over then to the red line or the pink line over?
Over here.
The far left.
Over
Far left.
here.
No, on the very far left. So it's like -4. What, like, where is that 3 from?
Oh, this one here.
Yeah.
Okay. So when you look at this, what you should see are two factors multiplied. You should see -4 multiplied by big stuff. But it's just two things multiplied. So on the next line, it will still be two things multiplied. But the power rule allows me to transform this. Remember, on a calculator, the calculator can do this computation. There's no need to do anything else. But we're trying to use these rules to get formulas that are more easily used without a calculator. So this transforms into this. That might help. So the 4 is just, that didn't do anything. But according to the power rule, you've got g of x to a number. So I'm going to apply the power rule to this red box. So you tell me what's the number
3
and what's the g of x? Say it.
dx.
No, good question. 3 points. So as you compare them, this d is this d.
Oh, so just that.
Yes, do you see it?
Yeah.
Much better. So this d is this d, the dx is the dx, g of x is just the x. So when you stop writing it this way, and we use equal to write it a different way, you're seeing it.
Yeah.
Yeah, the 3 here is here.
Okay.
That's that one. There's my g. Here's my 3 minus 1.
Okay.
See it?
Yes.
Good work. 3 points. Funny. Anybody else? Cool. We good to hear? Okay, hands up. What does D mean again? What's little d mean? Yeah, good enough. Difference, no points. Okay. So this says the difference in x divided by the difference in x, that's equal to 1. This is also equal to 1. So now you have this. These are all just multiplying, so I can write that more simply as negative 12. That would be negative 9. That's it. Now, sometimes they'll do this. It's not required, though. So this is not required. I think the back of the sheet has it written this way. On the AP test, you can stop here. Please.
Are you wanting us to write like which rule we use every time? Like how
No,
we
that's
decide?
just for your notes. Yeah, you don't have to write that. 2 points from Michaela. Anybody else? Please.
I just have a clarifying question. So on the degree where, like you said, that's where we can just leave it, can we just take out like, or just like, so negative 12x squared minus sin x to the negative, yeah.
Uh-huh. 2 points. Either way. Yeah, on the written portion of the test, they're very flexible. Those things all mean the same, so they'll take any answers.
Why do you want us writing dx over dx? It just could be a 1 every.
It's going to become 1. In a few days, we'll do some problems where you'll use the rules in exactly the same way, which is the good news, right? You don't have to really learn anything new. But the problems are going to be a bit more complex. And as you're using the rule, you'll suddenly find yourself writing this instead of this. And you go, oh, wait a minute. This is 1. I didn't really need to write it. This isn't. Yeah. So I found that it works a lot better to just say, hey, I know it's kind of a pain, but just write dx for a couple of days. And then once we start writing this, you'll say, okay, now I understand the difference, and I won't make the mistake. That's all. So, okay. 2 points. 3, actually. 4. 4 is good. Just got to weight the relative importance of his questions. Anybody else? Perfect. Another example.